Good afternoon, everyone. Welcome to this session. So this is not about automotive as some of the previous talks that were in here. We're going to talk about iOS and how to run Qt on iOS. So we're going to start talking about how you set up your project, some very basic stuff about the platform and how you start with your projects. And then we're going to talk a little bit about the user interface and what you can use to do your UI, whether you should use widgets or QML. And then we're going to look a little bit about how you integrate with the stuff that actually Qt doesn't support to, how you use the native platform services. So we're going to actually look at some Objective-C code. Please don't all run away. And towards the end, once I'll show you a little demo that integrates some of the stuff you can do when you want to interact with some of the platform-specific things. And then we'll look at the very end at the performance tools. So we're going to spend quite a bit of time in Xcode and not necessarily just Creator to look at that. Okay. So Qt for iOS has been available since 5.2 really as a tech preview, but has been more complete since 5.4. It's a static build of Qt, so it's rather unique in that aspect, which introduces some issues that creators actually and QMake is actually quite good at hiding from you. But it basically means you're stuck with QMake. You can't really use CMake or any other systems for that, or it becomes really difficult. Okay, so all the non-UI layer of Qt compiles as normal. QPA uses the native tools of the platform. I'm not going to go into too much of that right now. And the UI, we'll come back to it a bit later. All the UI is, especially comes to QML, is all driven by OpenGL. Now OpenGL uses Apple uses OpenGL for its user interface throughout all its platforms. So the support is very good there, although it's a bit aging. So the latest iOS will have OpenGL ES3, but not 3.1. And I won't talk about the desktop, it's outside of here. The minimum iOS support for Qt right now is iOS 8 and up as of Qt 5.5. And I don't think that's changing in the upcoming versions. What do you need to start working on an iOS application? You do need a Mac. It doesn't need to be very powerful Mac. It can actually be a VM, but it has to be, because of Apple licensing, if it is a VM, it has to run on a Mac. You need an Apple ID so you need to sign up with Apple Developer Program to actually have the rights to run an application on a device. Okay, so the sign up is free for your own personal use. For business use, it's fee-based, but relatively cheap. And you'll need to install all the Apple dev tools, namely Xcode. So Xcode basically includes everything. It's one download that you get from the site, and it includes all the tools that you'll need. All right. So I have a very quick look at how you work in Creator. Just looking at the preferences, you just check your Qt versions, check so you have iOS. It can be a separate download if you're using the pre-package. If you're building your own, you just build using the cross-compiler options, and it's pretty straightforward. And in terms of kits, so you'll see there's actually two different types of kits. There's iOS, which is iPhone OS, which is to run on the device, and there's iPhone Simulator, which is to run on the simulator. We'll talk a little bit about the simulator later on, and that's all you're going to see today, because I can't show you both the screen and my phone. And then, in the other options, there's in Creator, there's options about the devices. There's only one option. There's not much to set up. project settings in Qt Creator up here. Don't know how it is up here, but there's some weird bending effect here. So yeah, when you set up your build system, either for iPhone OS or for iPhone Simulator, there's nothing really special about it. It's all based on QMake. If you do look at the run settings for simulator-based, it will normally here show you the list of simulators that are installed on your application. Now Xcode 8 has broken this for Qt Creator, so the list here is empty, which is one of the reasons why I'll be showing more of Xcode than of Qt Creator for this talk. Hopefully an update to Creator will restore this functionality here. If you're doing native builds to run on the actual device, the device that will be you can run on, it will appear here in the run device. Again, it doesn't show up. One, because my device is not connected, but two, because Xcode 8 broke that. And otherwise, in terms of the projects, so standard QMake project and the things specific to iOS are really pretty simple. But you just create a project and then you run it. You build it and run, and you should be good to go for any simple QML or widget application. Can you guys read this, or is it a bit small? It's a bit small. There's a problem with my Creator. Somehow my keyboard shortcuts don't work anymore. Well, not the Zoom ones at least. So I need to go to here. Is that better? Right. So once you build, what you get in your build folder, should have not closed all my windows, QtWS. This one here. Okay, so what you get is basically a build system that's very similar to what you would get on any platform, but the particularity of the iOS platform is that it actually creates a Xcode project. Okay, so there's this file here was actually a bundle. You can open in Xcode. And if you go into Xcode, so that's the file explorer here, you have access to all your files. Keyboard shortcut doesn't work on Xcode either. It might be my key. So you see, have access to all the results of the build systems that QMake generated. So some of this is your source code. Some of this has been generated by QMake. Because it's a static build, you need to statically link all your plugins. So that's the default plugins, like things for images or location, things like that. And it's all the QML plugins. So it scans your code and scans the QMake file, and it scans the QML files for whatever imports you use, and QMake will generate these QML macros for you. So that's one. If you don't use QMake and you want to stick to CMake, that's one of the things you need to maintain by hand. So once you run here, and again, normally you could run this from Creator, but because of Xcode 8, the link between Creator and the devices or the simulator has been broken. So I can actually just run this from Xcode, and it's going to start up the simulator. Okay, and that's a demo. So this is QML application, so simple list view, and you can also see the map, and there's the good old clocks QML demo in here, and you see the basic navigation. And I'll come back to how this was put together during this talk. But basically, you'll see, with the exception of currently having to go through Xcode to run your application, it's pretty much just as any other platform. Okay. So what QMake generates, I just talked about some of those things. One of the very important things QMake generates is this plist files. So if anybody here is used to Android, you'll know about Android manifests, which basically configures some of the properties of your applications and the various capabilities you want to request from the operating system. And the plist file is an XML file, which is very much the same thing. Okay? Now, QMake will generate one for you, but you'll very quickly learn that you want to tailor your own and edit it manually. So we'll show how to do that in just a bit. Yeah, nothing much otherwise. The two plugin file related files I talked about just previously. Okay, so once you build an application on iOS, is actually what's called a bundled. So it's actually a folder with your executable in it, that plist files, and it has a special subdirectory structures in which you can bundle your own resources. If you don't want to put it as Qt resources, which will be statically linked in your application, but you can put any old files in it. And you can also, the bundle also contains specific applications, folders in which iOS expects you to store things. So there's a documents folder. All the applications, I'll come back to it, but they are sandboxed, which means they can't they can only access their own document folder, not the one of any other application. And then there's a library file folder in there. There's a specific folder called library cache in which you should write all the cache files that you might want to generate, things you download and want to keep locally. You just need to expect the operating system to delete those files if it needs the room. So you can't rely on those files always being there the next time your application starts up. Okay, at the bundle, this plist file, it contains lots of information about your application, who the author is, what restricted platforms you want to support, all that kind of things. Now, Qt will let you control some of these from QMake variables. So QMake has some built-in variables to control the deployment target. So deployment target is the minimum iOS version you want your application to require. So by default it's 8, but you might want to up it to 9 or 10 if you want people to be really on the latest one. And there's a couple of other variables that I'll show here. So for example, once you build your project and open it in Xcode, sorry, you'll see some information on this page, and that's basically a view into your plist file. Okay, so here you'll notice this application is built. I should have reverted to that. So the default is to build a universal application. So they work both on iPhone and iPad. So there's a very distinct separation between the two in iOS, unlike Android. And basically you can request to limit your application to run on either one of them. So here, restricted to, for the iOS targeted device family, that says I want to support the family 1, which is iPhones, and then you have family 2, which is iPads, 3 for Apple TV, and 4 for Apple Watch. But in this particular case, you can say 1 and 2, I want my application to run on either one of them. Typically, so if I was to build that and go back to Xcode, here it becomes universal application here, and you can control various things in it. I was saying earlier on that it's actually a good practice to bundle your own info.plist files. The way you do that in QMake is just by using this variable. And once you do that, this plist file becomes part of your project. So if you don't know how to start with it, you just take the one that QMake generated the first time, copy it into your source code, and start hacking it. Okay? And there's lots of things in there. There's various scripted key. The documentation for the Apple dev kit is pretty good. So if you want to learn what the particular keys does, you can just go and look at the various files. Yeah. So in particular, one of the things here you can customize is which orientation you want your application to support. So you can say most phone applications, you only want to have them work in portrait mode, never on the side, and certainly not upside down. But on other devices, you might want to change this. So in order to control this, there's no way of doing it from QMake. You need to use these plist files. Now, if somebody had time, they would write a plugin for Qt Creator that would let you edit these controls from Qt Creator the same way you can do it for manifests, but nobody has had the time. So once I build this, can't remember if I built. Okay, so it's reloaded. Notice my project has changed, it's reloaded that. And here you'll see previously the default is to support all orientations here. But you'll notice because in my plist file I only listed this, it removed the portrait. Okay? And if I wanted to support upside down, I can edit it here, I can save, and Xcode will have modified that. So you have some user interface to edit this file from Xcode. You need to be a little bit careful about what you do, but this is a possibility for these simple settings here. Okay. So yeah, typically you will bundle your own plist file into your application. It's also good practice. I don't know if you know much about QMake, but to use the substitution feature to sort of replace some values within your plist files, where, for example, version numbers and that kind of thing. These value names, just a heads up for people going to work on 5.8. Some of them have changed, or at least they've introduced a new, more uniform way of naming them. That guy there did the change. We've introduced in 5.8 support for tvOS and for watchOS. So it was getting a bit ugly to have these QMake tvOS deployment targets and QMake watchOS and whatever. So they're being renamed to QMake Apple. Okay. I don't know if you noticed in the project file. Here the conditional for iOS in QMake. There's also one for tvOS when you want to target specifically that platform. And if you want to target for the options that are valid for both, there's also a UI kit now conditional for configuration for QMake. Okay. Sorry? Okay. Yeah, true enough. plist template, I won't go into too much detail, I'll just show you the file before. How you handle icons and splash screens. There's two ways of doing it as resources. So you just put all your PNGs into your resources, and assuming they have the exact right size and the exact file name, Xcode will find them and use them. Now it has the habit of changing them from one, or at least adding to them from one release to another. So it can be a bit difficult to track. So the other way of doing it is to use asset catalogs, and that basically in Xcode you can ask it. Do I still have it here? So here, by default, you can add to your project what's called an asset catalog, and that's basically a folder of files that Xcode will generate with descriptions of your various icons, and it has all the placeholders for the sizes of icons that you need to support. Now it needs lots of different types of them depending on where it's going to show the icon for your application on the phone. And it lets you provide all the custom ones that you want so that you can control how downgraded they get at the various smallest size. Okay? Once you've asked Xcode to generate an asset catalog, I will not migrate the launch image here. If I build here, if I go to my build folder, where did it go? Oh, I think it goes in. Begins here. So this was just generated by Xcode, which means this file lives in your build system. So you don't want that. You want to move this back into your own project file once you've edited with Xcode. Sorry. So you'll see there's a bunch of files that it has generated here, and if I go and edit it, XC asset app icons. It's probably hard to read on the screen right now, but you see there's all the placeholders for your icon files. So it tells you which size they need to be. You take them, drag and drop into this file, hit save, and you're good to go. But the important thing to realize is that this file is in your build system. So you need to take it, copy it back into your source folder, and then instruct yes to all, and then instruct QMake to copy these files back into your bundle from your source into your bundle. Okay, so icon files can be copied from assets just like that. Okay, there's no uniform way of controlling the icons for your application. It's the same for the Mac, and on Windows there's different ways of building them, so that you have to go with the specifics of the target. Okay, so yeah, I've said it several times before, but you're going to have to get used to use Xcode. It's a rather good IDE, at least that's what I think. And it has an excellent debugger and lots of performance analysis tools that we'll see in a bit. Now, when I show you the running application, this was running in the simulator. Okay, so it is a simulator, not an emulator. It runs very differently than an actual device does. So what you're doing, you're actually cross-compiling your application not to ARM for the device, but you are cross-compiling it for x86 or x64 and running in the simulator. Your simulator has as much memory as your computer does. Your simulator has the CPU of your computer. It's a very different thing compared to your device. You will not get memory warnings in the simulator. We'll come back to that in a bit. And some of the things you can't really handle completely. It has very limited support for multitouch. You can only do 2 points, and even then it's 2 very controlled points. The OpenGL is very different. The sensors are very different, all that kind of thing. So yeah, very, very important to get to run on real hardware as soon as you can. It's usually as simple as plugging it in and getting it to run. That's assuming you have signed up to Apple's developer program, because you can't do that otherwise. Running on real hardware is a bit more complicated because you have to start dealing with code signing, which can be a bit of a battle. So code signing is actually very easy to set up now. It used to be a real hurdle, but you go to the Xcode preferences, and here you just enter your login and password for the dev site, and from there on, Xcode should handle most of the work, assuming you've got properly signed up. Okay, so when the first time you run on a new application, it'll need to talk to the Apple servers to get a code sign-in certificate, check that you are who you say you are, get a little certificate to sign your application, and that's where things in your plist file come in useful. Where is it? Yeah, the bundle identifier is the unique thing that's going to identify this particular application within the store. So you need to set that up a little bit before. Where's my preferences? Close. Yeah. So you need to sign this up. And then based on that, the first time the application Xcode needs to run on the device, it'll go and talk to Apple servers and set things up. In Xcode 7, Xcode prior to 7 was a real miserable experience because you needed to manually do a lot of stuff. Xcode 7 actually notices that some code signing things are missing and has a fix me button for you to tell it to go and talk to the servers. Xcode 8 is even smarter, and it does that without you having to click the fix me button. I don't know why they didn't do it the first time around. But anyway. So now that mostly works. Code signing, normally it just works. Sometimes it's still a bit like that. Yeah. You don't know why it's not working, or you've plugged your device and it's not being recognized, and you but there, it's technology for you. Right. So one thing I briefly mentioned earlier on is that the applications run in a sandbox. So they have only access to the bundle data and a couple of directories in there, and there's strict rules about where you can write into these folders. That also means a lot of other things about accessing what's called private APIs. So normally when you develop for iOS, you're only supposed to use the official APIs. Because Objective-C is a very reflective language, you can actually go and poke and things that are going on into it, and you can go and access some things that Apple's actually don't want you to access. If you do that and submit your applications, there's a good chance that Apple has the tools to detect that and reject your application from the store. If you don't want to go near the store, if you won't have your some companies can have their own stores, or you can distribute internally, then you're fine. It's only in order to go to the store. In order to be able to share data between multiple applications, at least between the application that you yourself write, you can enable application groups. And in this particular case, there's a special bundle, special folder that's created by the operatings for you, and that's made available to all the applications within the group. But that's all your own applications. You can't start sharing data with the Dropbox application, for example, without using something special like their SDK, which probably involves a trip via a server or copying of files from one bundle to another. Okay, user interfaces. Widgets. Who here would use widgets in an iOS application? You could? I wouldn't. This yeah. Yeah, I had to. Imagine tapping on these little controls here on a touch screen. Just can't do it. So yeah, don't. QML is probably the way to go. If I self-build Qt for iOS, I usually disable widgets just to save me the compilation time. Yeah, compiling your own Qt for iOS is a long process because everything gets compiled 8 times. Every single file gets compiled 8 times. So, yeah. Debug release simulator device 3264. So yeah, sorry, let's segue. QML is the way to go, I think. All written in OpenGL and supported by the platforms. You all know basic QML doesn't have much support for any advanced controls. So QQuick controls, it's a bit miserable again because they look exactly like this, the same way. They scale better, but they look awful. Are some little things in QQuick controls, QQuick control 1 at least, that are quite useful. The combo box will automatically bring up a little spin box thing, well, that you can, this little spin dial thing that's native on iOS. Stack view is quite nice to handle things like transitions from one view to the next. The file dialog, it's mostly users, because normally on iOS applications you never show files to the user, but there's a special case where you can set the folder to file dialog shortcuts pictures, in which case it will bring up the image picker, the native image picker, which is good, nice thing to have. Text input is a little bit better than the input field, but we'll come to that in a little bit. Like with any iOS application, and it's the same on Android, things like avoiding the keyboard. So you have vertical keyboard that comes over your application. Okay? Avoiding the keyboard is a real pain. So just as a demo here, there's an input field here at the bottom. Qt's default behavior when you do that is when a focus goes into a place that is underneath where the keyboard will be, it scrolls up the entire application screen, which may or probably may not be what you want it to do. You probably just want to move the field or resize your application in a nicer way. There's no built-in mechanism in QML for you to do that. There's actually no built-in mechanism in a UI kit in the native toolkits for you to do that, not in a general way. If it's in the list, then yes, because you can just scroll the list. But otherwise, there's no generic way for you to do that. So, yeah, you need to look at it a bit at how to avoid this problem. Okay. Just a quick word about QQuick controls 2. They are much better. They were targeted for the mobile devices. They look like Android applications. So if you ship that directly on iOS, people are going to say, this looks like an Android application. You can customize the look. There's no native look and feel for iOS, mostly for good reasons, because there's very little, apart from some of the iconic controls like the switch or the slider or things like that, there's really no native guidelines for how to do a button or how to do a menu or anything like that. Quick word, how am I doing on time? Right. QML also for handling of Retina displays. So all the new iPhones and everything since the 4S is what's called Retina display. So high resolution display. The way Apple has natively handled that, so the initial iPhone was 320 pixels wide. The Retina display was 640 pixels wide, but rather than breaking all the applications and making them appear in the top right quarter of the screen, they actually report the size of your screen in what they call points, and that number hasn't changed. It stayed at 320. Okay. That means the application is effectively addresses the same point space, coordinate space, but is being stretched by the operating system. Now, for things that are all vectors and text and things like that, it doesn't matter. It looks fine. Of course, things that are made with images, it looks horrible, because an image that was designed for 200 by 200 pixels, for example, is scaled to fill 400 by 400. So it's stretched and it gets all blurry. The way Apple handles this is that in order to support both that and the older phones, they have these @2x notation. So when you give the name of a file, if it's on a Retina display, it will look at first the file with a name with @2x added to it. Okay, so foo @2x.png. And that should be 400 by 400 to fill a 200 by 200 point display. That's the way it does it, and there's @3x for the biggest iPhones that you get now. It's best to embrace this, and it's actually the way that high-res support for images works on most of the systems now through Qts. Okay, QKit controls, I talked about it. QKit controls 2 also. Native appearance, as I said, you know, there's no built-in toolkit for you to do that. So it's going to be up to you to build your own applications. Okay, so I'm told there's an iOS style coming for QKit controls too, is that right? That's maybe, okay. That would be good. Personally, I think it's not such a huge deal. I've been involved in creating lots of mobile applications, and a lot of them will have very distinctive look and feels anyway. So they're going to have to customize the appearance of your applications, provide all your assets anyway. You're going to build your own controls, your own buttons, and anything. So, yeah, it's a pain because when you start from nothing, then you have to build everything. But for your most applications, they will have to do that work anyway. Now, yeah, just talking a little bit, so not just about buttons, but about the application navigation principles that you find in iOS. So the page navigation tabs, the master detail view, having a list of items, selecting one, and have more details about the selected one. All of that. Nothing but is provided. These are idioms that are provided by UIKit, but there's very little support for that in Qt. QKit controls has actually, the controls 2 has actually a lot of them that come with it now, so it's a much better place to be. But it's important to study a little bit what the platform-specific ways of doing the navigations are in order when you build your QML application to do something similar. Okay, one of the issues with QML is often that you end up loading your entire QML at startup time. One of the things I didn't mention is that the QML for iOS does not support the just-in-time compiler. So everything is, all the JavaScript is interpreted, which can be really slow. It can be noticeably slow compared to other platforms. Again, it's a good reason why you should test on the device. But it's quite important to structure your architecture so it doesn't load the world when it starts up and sort of progressively loads pages as it needs them. You can, of course, use the loader, but that's destructive. So you get one view, and then you load another one, and it goes completely, destroys the old one, puts the new one up. There's no transition from one to the other. Of course, you can use components, and that's what this demo application does. When you switch from pages to pages, it dynamically loads the new page, creates an instance of it on the side of it, and then zooms the current one out, slides out, and zooms the new one in. So it's ugly and slow on this, but it's purposefully just to show that at a given point in time during the transition, you have the two views visible here. One of the guiding principles is always to assist the user in when you transition from one view to the other. Okay, so just one way of doing this using components. Other things that I won't talk about is how you handle phones versus tablets. Very different layouts. iOS, the native toolkits have support for handling this, but there's nothing in QML, so it's up to you to build that. Either you would decide to load up two different sort of home main pages, depending on whether you're running on iPhone or iPad. Up to you to decide. Handling portrait and landscape also can be an issue, changing from one to the other. Cross-platform configurations can be a real pain if you're running the same application for iOS and for Android, especially in handling the different screen sizes and resolutions, because Android has a different way of handling the high DPIs. But again, you need to think about it first and come up with a solution that's the best for you. There's just not a single way of doing it. Support in the rest of Qt is actually now pretty complete. The sensors is complete. Thank God, I don't know which version it was introduced, but the compass module returns now both the true north and the magnetic north, which it didn't previously. You can ask me afterwards why that was a pain. Camera positioning, so the GPS and the maps are supported, so in the application. In-app purchases also works. Qt3D works. You'll see there's a demo on the Qt company booth about having the Qt3D running on tvOS. So that's the same principle. So most of the modules have support, but not for everything. One of the things that's missing, for example, is WebKit. So the Qt WebKit is not the old WebKit and the new web engine are not supported. So there's a module Node-Q Web Engine which will let you load the native web view and interact with it, but there's limitations to do that. And then there's lots of other things that actually Qt doesn't have any abstractions for. So like file type association or background operations, that kind of thing. Sharing is a big one. So how do you share a piece of content on Facebook or on Twitter? There's no uniform Qt API that does that, so we'll need to go and do some Objective-C to do that. Software platform-wise, I'm not going to go too much about that. So in order to use the native toolkit, you need to use a language called Objective-C++, which is a great invention. So Objective-C is a strict superset of C. Objective-C++ is a strict superset of C++. It's a space where you can write both Objective-C code and C++ code within the same source file. So the source file needs to have a .mm file extension and add it in QMake to the objective sources, in which case it will be compiled by Clang slightly differently. But within that space, it becomes very easy to mix accessing to Qt and accessing to the UIKit platforms. So for example, one of the things you can do is to use a QQuick item, your custom QQuick item, to create a component, a native component, that will be rendered over your QQuick item, position it. So basically the idea here is to have a QQuick item. You get its position on the screen, and you create a native view and place it at that position on the screen. And then that native view will be rendered above the QML scene. Okay? So that's one way, that's how the web view works. That's how you get a web page to display within your application using the Qt web view. It uses this process here. The major problem with this is that your view, this native view, comes on top of the QML view, which means you can't render on top of it, you can't flip it or do fancy animations that you can normally do with QQuick items. Okay? So that's what the WebKit web engine, the web view, does. There's a simple example here of how you do it for a text area. So the top one is a native iOS one, and the bottom one is the QQuick controls text area. Okay. And you'll notice they behave slightly differently, especially when it comes to selection. So here you can select a word and you can extend this. The native one, the things you would expect, has this little loop. Now this is on 5.6. 5.7 is actually much closer to the original. So when I did this example, the difference between the Qt text area and the native text area was very big. So if you were writing an application where the user would have to type text, a lot of things like correction or this selection and things like that just didn't work. Now it's less of a problem, but it's still a demo of an example of how you do that using, I'll probably show it to you in here. Text view, QQuick item. And basically you need to handle the geometry change to resize the native view. And then the window change, this is when you have the opportunity to create your view, the native view, and you can also override on visible change to show and hide your view, basically. And then the implementation of this, so this is in a .mm file where that can include both C++ and UIKit. So UIKit is the native toolkit to do user interfaces. And basically you create the view like this. So this is Objective-C and C++ mixed in the same file. Okay? I can make the example available to you if you're interested. Another way is to use the QPA. So if you go into the private API, you can request the top-level view and sort of manipulate it and access it like that. I'm not going to show any example of it, but that's how the kind of code you need to get access to the top-level view that the QPA creates for you in order for the application to render in. Very short on time. I'm going to skip the section on delegates because it's not that important, and just quickly finish talking about profiling and debugging. Now, when you run the application, the tools within Qt Creator to do profiling work just fine, especially the profiling for QML. So if you want to debug your startup time, you can use the profiler to find out what's getting loaded and how long it takes. So all of these tools work fine. The debugger works fine, including the QML debugger. But for some of the performance analysis, you sometimes need to go back to Xcode. Now, Xcode has a huge number of tools for you to do performance and debugging. It's actually a really good debugger. It doesn't know about Qt's data structures, unfortunately. But for the native stuff, it's actually really useful. When your application is running, which it is, you run the other one. Startup. Here, so when the application is running, which it will do in a few seconds. Okay, so that started the application, and while it's running here, you have access to debugging information about the CPUs. It will track load over time. So if you do things in your application, you can track the load of of your application. You can also track memory allocation and see it evolve through time. Disk I/O, network I/O. In this particular case, I'm running on a simulator, so it doesn't show it. But when you're running on a device, you get lots of information about the OpenGL state, so the frame rate and all that kind of thing. And then for all of this, there's also included with Xcode an application called Instruments, which lets you do much more advanced profiling. So here, I can profile in Instruments. Oops. And that basically gives you a much more detailed view about what's going on in your application. The memory one is really good at tracking memory leaks, and you can also do record the state of an application, do something, record the next state, and see the differences between the two. So all the data that's been allocated in between the two, really useful. Do learn to use this tool. It's very powerful. And it comes for free with Xcode. So those are all the instruments that come bundled with Xcode. Some of them only apply really if you do Objective-C applications, but it can be quite important to some of them, like the For performance, for the memory allocations, are really useful. You're probably not going to use core data, but you can monitor things like the network activity, how much energy your application uses, all that kind of things. A lot of colleague who goes on a lot about energy optimization of how you write an application that uses the least memory as possible. And the last thing I want to bring up is that it also comes with, I can't show it because it only works when you're connected to a device, but with an OpenGL frame debugger. So you can actually grab a frame and go through all the rendering stages of the debugger. If you're doing some 3D, it's quite useful, but it's also useful for QML because you can go and inspect the big texture that gets created for QML application and see what gets loaded and see all your draw calls. So yeah, common things to look for is the slow startup, the lack of just-in-time compiler, memory allocation. iOS doesn't have any virtual memory, so as soon as your application uses too much, you get a few warnings that your application is using too much memory, at which point you should probably try and free some. It's not always as easy as it sounds. And after a few goes, your application might just get killed by their operating system. Yeah, graphical effects also, if you use them on iOS, they can tend to be really slow, partly due to the Retina display that's it's actually needed. It needs to go through a lot of pixels to do some of the effects. And finally, yeah, external testing. With Xcode and the iTunes Store, you have something called Test Flight, which lets you upload your application and make it available for a limited number of beta testers. So they install an application on their phone, they register with you through Test Flight, and they get notified of new builds. So that's a great way of getting beta testers involved. There's also Hockey app, which is a website-based services that does similar things. That's also cross-platform. It also supports Android. I've never used it, but Amazon Web Services have the device farms that lets you run applications on a whole bunch of different phones and see how they perform. But yes, that's basically it for now. Thank you. Sorry?
So did you guys have any questions you guys like to ask? I'll come around. We'll start up here at the front, and I'll make my way to the back.
Have you been able to do anything to get the Qt footprint down on an iOS device?
In what aspect? The file size or the?
Yeah, the in-memory.
The in-memory. No, not really. I think it's always the same problem. You know, minimize the plugins you import. If it's really a problem, you might want to look at building your own Qt to disable all the things you don't need. But because it's a static build, everything you don't use normally will get trimmed out when you do the final linking. So there's really not that much you can do, I'm afraid. But it's a very application specific.
And you might be able to use Qt Lite to trim the application size down some more if you build your own version of Qt. But that remains to be seen how much you'll actually be able to save with that.
I've never tried that one.
Let's go back first.
Thank you. Is your presentation, your slides available on the conference website or someplace?
I don't know what's going to be the policy for this conference, but I can certainly make them available.
Yeah, well, we'll be making all the slides for different presentations available on the website afterwards. Yeah.
Yeah, we are seeing like the specifics about iOS, Qt on iOS, and you say there has to be a lot of things that have to be imported back to the Qt project and everything. So my question is it now a possibility to use Qt on different Android, iOS, and Windows? I mean, like a real application with all the specifics?
Well, what do you mean by specifics? But
yeah, like for example, we saw all the things that you have to do manually, like with Xcode, and then you have to import it back to Qt project. Right. But if we want to do this same application on Android, probably there has to be something like that. Is it viable to do an application in all platforms?
Yeah, I've done it a number of times, but you just need, for these platform-specific things, like the application icon. If you do it for Mac and for Windows, it's two different ways of doing it already. There's no support in Qt to do that. It's the same for Android, it's the same for iOS. It's probably the same for Windows RT, I don't know. But I've shipped a number of applications that across at least the Android, iOS, and Windows phones support, Windows tablet support, and that's fine.
At the end, it's the one Qt project.
Yes, yeah. So using the configuration variables, you're going to have fairly chunky sections that are specific to each platform, but it's the one project.
Excellent presentation.
Thank you.
First of all, I have a QML application. When I run it in iOS, I often run into a shallow call stack on iOS that I don't see on other platforms, where I get in the QML, I get QML warnings saying call stack exceeded, even though it's not recursion. It's just normal application stuff. So I'm wondering if you've run into that, and if so, if there's some way to configure a larger call stack for iOS.
I'm pretty sure there must be options for Clang to control the size of the call stack. I don't know what they are off the top of my head, but no, I've never seen that particular behavior before. No.
As a side note as well, in the Qt garage downstairs, we have a live support desk. So there's some Qt engineers that you can also kind of reach out to as well.
Hi. We are using CMake for our Windows and Linux applications, and I was wondering if you would recommend more QMake than CMake.
Well, the main problem with CMake, you can very easily build libraries for iOS. It's really it lacks the support to build complete applications, the final bundle. So it can be made to work. But it's very problematic. So one of the issues one of the things it doesn't do at all is the dependencies with plugins, whether they're Qt plugins or QML module plugins. You have to do that manually, which is a bit of a pain.
So I saw you had mentioned that support for tvOS is available in 5.8.
It's a tech preview in 5.8, so it's not built by default. There's no pre-built ones, but you can build your own. Yeah.
And does it work? Can you actually use the controller and move between the icons?
Yeah, you can. I'm doing a lightning talk on that tomorrow.
Oh, great! Thank you.
And there's a demo on the Qt company booth downstairs.
What about the completion of all the modules? Because, for example, printing is still not possible.
No, there's no support for printing yet.
And will you do it or not?
I personally will not. I don't know if it's on the roadmap of anybody. Again, open source project, so it can be contributed. The support for, I'm actually not very familiar with the native support for printing. So I don't know how easy it would be to integrate with the Qt's print support library.
Hi, is there separate configuration for simulator versus regular iOS? Because with external libraries, you have to compile for the right architect.
Yeah, that's actually changed a little bit. It was changing in 5.8. There was completely separate libraries right now. 5.8 actually merges the two in fat libraries that have the two built in. It's going to be a mixed bag to use because Qt Creator hasn't yet been updated to handle that configuration.
Is it possible to somehow access NS defaults from within a QtQML application for iOS?
You need to fall back to Objective-C++. Okay.
And
which is often is just a one-liner. You can expose from Objective-C++, export a CD function, and then you do your calls through that.
Is it also the same for the core data?
For?
Core data?
Yes, yeah, you can do the same.
Okay.
It becomes a bit more complicated because a lot of core data is asynchronous, but yeah.
Cool. Do we have any last questions before we wrap up here? Great. So I want to thank Mike very much from KDAB for joining us today. Big round of applause for Mike and going through all the wonderful iOS. We have this copy of the book signed by Kevin for you.
Great.
Enjoy. Now it's a break for about 40 minutes. Welcome to go check out the Qt Garage, see some demos, ask some questions of staff and engineers, and then sessions kick back on right up after at 4:20. Yes, forget my timings on there. Enjoy.